Okay, let's look at our first reaction. This one is called a synthesis reaction. So what synthesis means, if you think about it, is you have one product or reactant and another reactant coming together to form one product. Many of you are probably familiar with the word photosynthesis, and that means to bring light together to create something. In this reaction, I'm going to pick something different for our synthesis reaction. So let's say that we have lithium as a metal, and we have chlorine gas, which is diatomic, coming together. So what's going to happen is we are going to produce a product, and we have to think about the charges on these two because we have a metal and a non-metal, which means we'll have an ionic compound forming. So if lithium were to become an anion or cation, in this case it will become a cation with a +1 charge. Chlorine will become an anion, it's a non-metal, it will take on a -1 charge. So when they join together, we will get lithium chloride. Notice that our subscript here does not matter on the other end. We'll talk about balancing equations later and where that too will take place. All right, our next type of reaction is called decomposition. So if you think about the definition of decomposition, it means to break apart. With it being fall right now, we think about our leaves and they're decomposing. Their colors are changing from green to different colors. So if we look at another example of what exactly is decomposition, it's the opposite of a synthesis reaction. So in our last example, we had lithium and chlorine. So we had lithium chloride. That was our product. In this case, it's going to become our reactant and it's going to break apart and we are going to be left with lithium and chlorine. Since we know that chlorine is a diatomic gas, we know that that final product actually has to be 2. Again, we have an ionic compound breaking up into a cation and an anion. These are both stable compounds. They do not have any charges. And this part here doesn't have any charge as well. It is bound together because it's a neutral compound. So we don't need to worry about charges when we're doing decomposition, but we do need to think about charges when we are doing synthesis. Our next example here is called a single replacement. So just like it says, we're going to take one thing and we're going to replace it. So in this example, let's say that we have sodium chloride, and let's say we mix it with lithium metal. We'll talk about reactivity series later and why lithium can replace sodium. But assuming that this reaction can take place, lithium, which is acting as a cation, will replace sodium, which is acting like a cation. We need to take into consideration the charges on each of these compounds. In this case, sodium has a +1 charge and chlorine has a -1 charge. Lithium, if it becomes an ion, will take on a +1 charge. So when we replace them, we have to balance the new compound, make sure it's neutral. In this case, lithium and chlorine both have the same charges, so they cancel out. And sodium, since it's a metal, can be by itself. This is an example of single replacement. Our next example here is called a double replacement. Here we have one ionic compound, sodium chloride, and a second, which is called lithium fluoride. Just like with single replacement, only cations can replace cations. So in this case, sodium and lithium can switch places. We're going to have 2 products and both are going to be ionic compounds. So we must take into consideration the charges. Again, sodium has a +1 charge, chlorine has a -1, and lithium has a +1 charge and fluorine has a -1. In this case, it's easy because all have the same charges. So in this case, lithium will swap out with sodium, produce lithium chloride, and sodium will swap out with lithium to produce sodium fluoride. In this case, we have 2 reactants and 2 products. Our last reaction is called a combustion reaction. In this case, we must have oxygen present for the combustion to take place. So combustion, when you think about it, is going to be something that produces a lot of heat. Sometimes you might even see a flame. And in order for us to burn something, we have to have what's called a hydrocarbon. So if you think about the word hydro, means we have hydrogen, carbon meaning carbon. In this example, I'm going to use methane, CH4, or also known as carbon tetrahydride. When these two are heated up, we get a combustion reaction, and what is produced is always the same. We will always produce carbon dioxide plus H2O. So our oxygen and hydrocarbon are going to produce carbon dioxide and water, and it will produce a lot of heat. So an example of where this takes place could be your car engine, or even when you eat food. So when your car engine is running, you might notice that water comes out of your tailpipe. That's coming from your combustion reaction. You may not see it, but you remember knowing this in middle school, that carbon dioxide is one of the products that happens at the end result.